Today what we'll be doing is we'll be looking at Chapter 11, Section 5. And this section primarily deals with areas of circles and sectors. And we have done a little bit with circles in the past, but now we're going to get a little bit deeper in the sectors. So first of all, when we look at the area of the circle is pi r squared. Now, the difference between the area and the circumference is C is 2 pi r. So the difference is that with area, the radius is squared. And so that's your indicator on whether I'm dealing with area or whether I'm dealing with circumference. And when I look at area of a circle, it's the stuff inside the circle. It's not the distance around, but it's the stuff that's inside. So let's take a look at an example. It says, what is the exact and the approximate area of a circle with a radius of 10? So what you do, like we've done in the past, is we're going to grab that formula. A equals pi r squared. You always start with the formula. It's kind of like your recipe. Then what we're going to do is A equals pi, and I'm going to grab in that 10 squared. Okay, so now here's the difference between exact and approximate. If I am doing the exact, which is what this is, I would go ahead and I would just go 100 pi, and this would be, units squared. That's the exact. If I am going to do the approximate, what that would look like, I'd set it up the same. I'd still grab my 100 pi, but then I would go one further step and I put in 3.14, or I would use the pi key on my calculator. And if I do that, I end up with 314, and it would be units squared, and this is the approximate. So essentially the difference between the two is with the exact, you're going to leave pi in the answer, and with the approximate, you're either going to push your 3.14 in your calculator for pi, or you're going to use the pi key. And the directions should tell you that. If they don't in your book, I do have the answers, so you're going to kind of know that way. On your test, I'll be very transparent, and I will say use 3.14 or use your pi key. Let's keep going. It says a pi has the diameter of 12 inches and another has the diameter of 8 inches, and how much more pi is in the larger one? So let's go ahead and let's grab, let's do the smaller one. So this is the smaller one because 8 is smaller than 12. And I am finding the area. So area equals pi r squared. Area equals pi, and that's the diameter. So it's 8 divided by 2 squared. Area is pi, and that's 4 squared. And so area equals 16 pi. And I'm going to leave it in terms of pi right now. I'm going to go ahead then and I'm going to solve the other one, which is the larger one, because 12 is bigger than 8. So area equals, like I said, start with the formula, pi r squared. Area equals pi, and I've got 12 divided by 2, and that's squared. Area equals pi, and that gives me 6 squared. And I got area equals 36 pi. Now, I found the exact of the smaller pi, and I've got the exact of the larger pi, and they want to know which one is larger. So to be able to do that, what I would do is I would take 36 pi, and I would subtract the smaller pi, which was 16 pi, and I would end up with 20 pi inches squared, or you can figure that out using the 3.14, 62.8 inches squared. So it just depends on if they want exact or if they want approximate. And again, on a test or any type of problem that you have in your homework, they will tell you and you can check your answers as to which one is best. All right, let's keep going. It says the area of a circle is 74 inches squared, and they're asking me what the diameter is. So again, what we're going to do is we're going to grab that formula. A equals pi r squared, and they gave me the area, which is 74 pi r squared. Okay, and they want to know the diameters. So the process to do this, what you're going to do is you're going to find the radius first. So to do that, I would divide both sides by 3.14, so the radius squared equals 23.555. And again, keep it large in your calculator. You can abbreviate it in your work. I'm going to square root both sides, so I'm going to show what I'm doing. My radius ends up giving me 4.953 inches. Oh, this is 853 inches. And then to find the diameter, you take 2 times 4.853, and that would give me 9.7, and it would be inches. And again, it depends on round to the nearest tenth, round to the nearest hundredth. Never cut things off because that can skew your answer. The only time you round is in your final answer. Again, you can write an abbreviated version on your paper rather than writing all the decimal places out, but in your calculator, make sure you keep it large. All right, let's keep going. And we're going to look at sectors of circles. Now, we've looked at this before. Essentially what it is, it's a central angle. But the sector of a circle is the region bounded by 2 radii and their intercepted arc. What that really means is that green piece. How much piece am I getting? How much of that? If you remember from the past, we looked at the length. So we looked at this section right here. And the formula for that was L equals the measure of arc, we'll call it AB, over 360 times 2 pi r. That was the length of that red piece, okay? The area of the circle is different, okay? And you're going to notice it starts the same. So the measure of arc, AB over 360. But what makes this different is this was the length, and you're going to notice it's part of what you're essentially taking is a fraction of the radius or of the circumference. Here what you're doing is you're taking a fraction of the area. So that's what makes it a little bit different. So let's go ahead and let's use this new formula. It says find the area of the shaded regions. So I'm going to go ahead and grab the area equals the measure of arc, and it's AC, because that's what's shaded there, over 360 times pi r squared. If you start with the formula, it does make it easier, okay? Then what we're going to do is my area equals the measure of arc AC. Now you're going to notice that they didn't give me the measure of arc AC, but they did give me the measure of arc ABC. So I have to come over here and I have to figure that out. And I'm going to take 360 minus 240, which is 120. So I'm going to go ahead then and I'm going to take that 120 over 360 times pi, and then the radius, you'll notice here, is 5. So it's 5 squared. Okay? So now what you do, essentially you just do a bunch of number crunching. You just plug it in your calculator, and the area ends up giving me 8 1/3 pi units squared, or area equals, you can go 26.2 units squared. So it depends on whether they want the exact or they want the approximate. You just want to be a little careful when you plug this into your calculator, so I really encourage you to practice it. Make sure you know how your calculator works. Sometimes when I put it in my calculator, I will take 5 squared, and then I will multiply it through by the other things. All right, let's keep going. On this one, they want me to find the area of the circle. And again, if I'm going to find the area of a circle, of the shaded region. It's not the circle because the circle would be easy. I need to find the area of that shaded region. So what I'm going to do is I'm going to take the formula. A equals the measure of arc A B over 360 times pi r squared. And I'm going to keep going. You're going to know the measure of the arc is the same thing as the central angle. So 51 over 360 times pi times the radius, which is 7 squared. And practice that with your calculator. If you bring it through, you get 6.942 pi, and it would be meters squared, or area equals 21.8 meters squared. So again, it's really, really important that you plug that through your calculator. Make sure you know how to use that calculator. All right, so that's finding area of the smaller section. Now, on this problem that we're going to do, and this just gives you a bunch of different scenarios. That's why I'll assign certain problems. Do what you feel you need to do, but make sure that you take a smattering of a lot of different ones, because like this one is just the area of that sector. Where down here, you're finding the entire area of the circle. So what we're essentially trying to find on this problem is I am trying to find the radius. Okay, because the area of the circle is pi r squared. It's the entire circle, and you're going to notice that I don't have r. And I don't have the area of the whole entire circle. This is the area of just the sector. So to do this, what we're going to do is we're going to come off to the side over here, and I'm going to go, okay, area of the arc, and we'll call it AB, over 360 times pi r squared. The area of that sector is 25. The measure of the arc AB is 48 over 360 times pi and then r squared. So what I'm going to do is I'm going to multiply this through. So 25 equals 0.419 r squared. So I took 48 divided by 360, multiplied it by pi. Then what I'm going to do is divide both sides by 0.419. And so my radius squared is 59.67. I'm going to divide both sides, square root both sides. And I get r equals 7.72 inches. And again, you don't want to cut that off in your calculator. You want to leave it large. You can abbreviate it on your paper. So then what you're going to do is you're going to come back up here, and you're going to continue with your area. Area equals pi. And then for your radius, what you're going to do is put in that 7.72, and you're going to square it. So area ends up giving me 59.67 pi inches squared, or area gives me 187.4 inches squared. So again, it depends on what they're asking, if they want the exact or they want the abbreviated. Make sure, again, that you plug that in your calculator and you know how to use your calculator. All right, let's go ahead and let's look at this final group of questions. This is one that you're going to find on your test. You're going to notice that they give you the entire circle area, and then they also give you the area of the shaded region. and they want you to find the radius. So you can either decide to look at the entire area. Again, area equals pi r squared, or this area of the sector, the measure of arc AB, all over 360 times pi r squared. Okay, so to find the radius in number 1, what I like to do is I like to just look at the entire circle. I think it's easier. So again, on this problem, what I'm going to do is area equals pi r squared. They gave me the area of the entire circle, which is 104 pi r squared. I'm going to divide by pi, so r squared equals 33.104. I'm going to square root both sides, and I end up with my radius equaling 5.75, and that would be inches. It's not inches squared because that is not the area. So you'll notice that I found that using the entire area on the first problem was the easiest. Now when we go down to finding the measure of the arc AC, I have to use that other equation. And so what I'm going to do is I'm going to grab that equation. Area equals the measure of arc AC all over 360 times pi r squared. Okay, and it wants me to find, and this is where it's kind of layered, they want me to find this right here. And so I'm going to go ahead and grab the area of the shaded region, which is 36, and the measure of arc AC. If you wanted to put an X in there instead, that might be a little bit easier, but that's up to you. Times pi. And then my radius, I'm going to grab from up above. So this was 5.75 squared. So I'm going to keep going then, and I'm going to go 36 equals, and I'm going to take, let me show you, I'm going to highlight it. I'm going to take these and multiply those together, and then I'm going to divide it by the 36. So I end up with 0.2887 measure of arc AC. Now I divide by 0.2887, and the measure of arc AC ends up giving me 124.7 degrees. And it's degrees because I'm finding the measure of the arc, like the angle, the central angle. Okay, again, you want to keep your measures as big as possible. You don't want to be chopping them off when you're actually trying to find that. Okay, and then finally, it wants me to find the length of arc ADC. And so what you're trying to find on this circle is you're trying to find this arc right here. You're trying to find the length of that. Okay, so then we have to take a look at a different formula while we're doing that. So it would be the length equals the measure of arc ADC over 360, and I'm going to use 2 pi r. Okay, the length equals, now I don't know the measure of that, but what I can do is I can take 360 degrees and I can subtract what I found up here, 124.7, and that's why it's really nice to keep that big, over 360 times 2 pi, and then my radius I'm going to grab from up there, 5.75. So then I'm going to keep going. L equals 235.3 over 360 times 2 pi times 5.75. If you bring it all the way through, the length gives me 23.6, and that would be inches because that's the length of the outside. It's like a part of the circumference. Now, some students will ask me, well, what happens if I do the problem and I get my radius wrong? Like, number 1 is wrong, so now number 2 and number 3 is wrong. Like I messed up the whole entire thing, so I failed it. That's not true. That's the value of work. That's why it's really nice to show your work and let me take a look at what you're doing, because that will help you then when you're taking your test. Where if it's a multiple choice test or an ACT, you don't have that luxury. That would be wrong. So you need to be really careful with plugging your numbers in and not rounding too much. That is it for 11.5. If you have any questions, please feel free to ask me. Have a great day.